Our planet's climate is changing. There's no question now that what we are doing is having a dramatic impact on our planet's climate. Join me as I look at what the North East are doing in the fight against climate change. The final piece of our puzzle is adaptation. And to find out what this means when it comes to climate change, I've come to Newcastle University to meet Dr. Alistair, who deals with adaptation on a daily basis. Okay, so Ali, what do we mean when we say we're talking about adapting to climate change?
Adapting to climate change is ensuring that the things we rely on for everyday life, be it the food system that provides the dinner on our plate or the electricity that powers our homes, is able to continue to operate despite climate change happening. So we know that climate change is coming, is already happening. We need to make sure that we can continue to live the lives that we live and be healthy and carry on, our existence despite that change, and that's what adaptation is about.
Okay, so I mean, we've already looked at mitigating against climate change. How does is adapting not kind of giving up on the stopping it happening? Yeah, I mean, this is a discussion that's been had quite a lot in climate change circles. Is adaptation an admission of failure on climate change? Partly yes. We've had, what have we had now, 40 years of trying to act on climate change and haven't done enough. Mm-hmm. So as a result of that, global temperatures are changing. We've already got about 1 degree of global warming. Wow. We've seen that around, the global temperatures have gone up 1 degree since pre-industrial times. So we've got to adapt to cope with that, regardless of how successful we are at mitigating climate change. We could turn off all our CO2 emissions tomorrow, and we've still got to adapt. 1 degree. Yeah, and we're probably heading. I mean, the Paris Agreement says we've got to keep temperature rises below 2 degrees and aim for 1.5 degrees. So we're almost at that 1.5 degree. And I think 1 degree doesn't sound like all that much, does it? But it's the average temperature across the whole globe. Yeah, so that's one degree Celsius globally, as you say, average. But that means in certain places the change will be much higher. In certain places it'll be less. So, and that 1 degree, as you say, it doesn't sound like a lot, but the ecosystems of the world, the animals and plants, and us as humans are adapted to that climate that's been around for hundreds of thousands of years. We're not adapted to this new climate with its more extreme weather events and its higher heat waves and all of these other things that are coming. So we have to find ways of making sure we can carry on living despite these changes. Yeah. And so your work looks at kind of building risk assessments for cities and how they are at risk from climate change. Is that right? That's right, yeah. So I've mainly worked in cities, and cities are important because they are where most of us live on the planet. The majority of people live in cities now, and where a lot of our activities take place. It's where our economies are generally based and things like that. So they're important places to protect and to adapt to climate change. So what the work I've been doing is looking at how, alongside climate change, you've got other things going on in cities. So we know that cities are growing, there's more urbanization across the planet, more people moving into cities. And how do those, what we call socioeconomic changes, so the higher populations, urbanization, changes to the way that the economy works, aging population, so all of these other changes that are going alongside climate change, how do those two things come together in urban areas and cities? So it's not just about the changing climate, although that's clearly very important. It's about the other things that are changing too. And by putting these things together, we can start to understand the risk that cities face, and by understanding the risk, we can plan for this adaptation to keep that risk as low as it is today. So when we talk about risk, it has 3 parts you can think about. There's the hazard part, which comes from the climate change bit of the equation. So what would be an example of a hazard? So a hazard, if you think you have a heavy rainfall event, loads of water comes out of the sky, the ground gets flooded. That creates a flood hazard. Yeah. So it's some water that's a certain depth. Mm-hmm. If that water's in the middle of a farmer's field, then maybe it's less of a hazard than if it's in the middle of a city. Yeah. So the hazard is important, but what that hazard exposes to the hazard is important. So there's an exposure part of that risk as well alongside the hazard. So does the hazard
affect something that we're interested in? Does it flood a school or a hospital? Does it knock out an electricity substation? So that's the exposure bit. And then you've got the final part, which is the vulnerability part. And that's how well can that exposed thing cope with that hazard. So if you've got a metre of water and you flood a house where everything's on the first floor or above and the ground floor is just an entranceway,
vulnerable.
It's not that vulnerable. Whereas if you've got houses built in the traditional way, then that same metre of water can cause far more damage. So you're putting these three things together and you start to understand what the risk from climate change might be.
So say we've got floods, what kind of measures can we put in place in order to adapt to increased flood risks?
Yeah, so this is where this thinking about hazard, vulnerability and exposure becomes interesting, because you can target your adaptation at different parts of the problem. So you can target adaptation to reduce the hazard, and people here at Newcastle are doing research, say, on natural flood management, which means putting ponds or little barriers in farmers' fields up a river catchment and where the water comes from, so you can keep the water up in the fields, so it doesn't come down and hit the town at the bottom of the catchment. So that's reducing the hazard. It's reducing the depth of the flood water. You could think about flood ponds in cities as well, or what are called sustainable drainage systems. So you can reduce the hazard bit, you can reduce the exposure bit, and that's about things like land use planning. So we have started in recent years to build homes on floodplains, for example. Now that's not a very good idea, because that then exposes those homes directly to a flood hazard. So we can reduce the exposure through better land use planning and better use of land in that way. And then there's the vulnerability part. So we can reduce the vulnerability by different design standards. So we can say, when you build a house, all of the electricity sockets should be a metre off the floor,
level,
so that if a flood does happen, then they're less vulnerable to that flood water. So we can target adaptation, different bits of the system, or all three of those bits ideally, to make sure this resilience is in there for when these hazards come.
So I guess it's kind of a case of, adaptation, mitigation going hand in hand together, both of them together. But what happens if measures that you want to do for one conflict against the other one?
Yeah, and this is a big problem. That there are certain adaptations that we can put in place quite quickly that make mitigation more difficult. So think about a heat wave hits a city, the temperatures get really high. The easiest thing to do is to just put an air conditioner on every building. So when it gets really hot, you turn your air conditioner on, temperature stays cool, and you don't suffer from that temperature. Air conditioners use electricity though, so the danger is by using that adaptation, you use far more energy, more emissions, and you end up in a vicious cycle. So ideally you want to find adaptation options that don't sacrifice the mitigation part of the problem, and vice versa. We don't want to have mitigations that make adaptation more difficult. So if you think about land use again, one of the mitigation options we might have is to grow biofuels. So we grow crops, turn them into ethanol, and we use that to power cars or whatever instead of fossil fuels. But that land, if we're using it for biofuels, we can't use it for floodwater storage, perhaps, or we can't use it for building homes out of a floodplain. So we've got to think about
incredibly complex system, and I guess it's all about working together, isn't it? It's about the engineers working with the scientists, working with adaptation, working with mitigation, working with measuring, and finding out what it is that we actually need to know about it.
Yeah, and I think this is the difficulty, or the good thing, I guess, as a scientist about climate change, that it needs everything. It affects everything, but it needs everything to actually solve it. So I'm a member of something called the Tyndall Centre, which is an interdisciplinary climate change centre in the UK. So in there we have people who are economists, people who are psychologists, people who are engineers, people who are natural scientists and atmospheric scientists, and we all work together, because to solve climate change we have to do that. We have to understand all of the different parts of this system. And here in the School of Engineering we talk about systems all the time. We talk about engineered systems or infrastructure systems, because they are bits of interconnected parts that join together, and one part does something and it flows through to all the other parts. So if you've got to think about the system and how it interacts in order to solve the problems that we've got, really.
With the way we're going, we are already on track to pass the 1.5 degree warming limit, and even possibly surpass the 2 degree warming limit. There's teams globally and here in the northeast who are working on how we adapt to this changing climate. A lot of the conversation is about the possibilities of what we could do, but perhaps now it's time that we change to what we are doing, so that we can adapt to a climate that is changing and reduce the risk for you, for me and for everybody else.